Okay, hello everybody. I think we're still waiting on a few more people to show up, but thank you for joining us today on Wednesday afternoon, evening, wherever you are. Middle of the day, I guess, for you Pacific people. My name is Lee Brown. I am a curriculum and training specialist. My gosh, I'm gonna have to start over again. I'm a curriculum and training specialist for BioRad, and I've been working with BioRad now for about 10 years. We are going to present a workshop today that is really intended for people who are working with students interested in health science. You might be a HOSA advisor, you might be a health science educator, and talking about how you can incorporate biotechnology into your courses, no matter what those courses are, as long as they're in the sciences, obviously. So we've got a few teacher presenters for you today, and then I'm going to follow up with some other ideas. And we'll hopefully have time for some question and answers sessions at the end too. So please feel free though to interact in the chat. We have people from BioRad monitoring the chat. We have teachers in there that probably have answers as well. So please feel free to type questions in there. Yolanda, if there's something that you want to stop us and have us answer out loud, please feel free to do that, and we'll go from there. So let me get started here. We're going to start off talking about why would you teach biotech? Like what is the advantage to you? What's the advantage to your students in teaching biotech in your courses? Nick Hanley is going to step in, and he is a lieutenant on the national competitive team for HOSA. He teaches chemistry and Project Lead the Way, biomed, and he's at White Knoll High School in South Carolina. And then Sherry Annie is going to talk about one of the COVID case studies that she's been doing with her students. Sherry is a longtime I don't know how to explain it. She's one of our teachers that consults with BioRad regularly to help us come up with great new kits and kind of talk about how we can teach this in, or how we can bring labs into the classroom. So she teaches honors biotech at Brebeuf Jesuit Prep. Is that right? Sure. Okay. I think I said that right. I might have messed up. In Indianapolis. And then, like I said, I'll go over some of our other biotech labs and different free resources and things like that. So let's start off here. And I don't know if you guys have ever done this or not, but do y'all ever use the annotate function in Zoom? I used to have a little thing for how to do this, but I cannot find it for the life of me. There is an annotate feature right up in your menu bar. Do y'all see where that is? It's a little pencil. And on there you have a text option, and you can do text, and then you can type here on the screen like so, and it will show up for all of us. So if you guys don't mind adding there, using that annotate function and just typing in some of the things that you guys teach, might be biotech, might be biology, might be health science. I just like to get an overview of kind of what you're teaching here. If you can't figure out the annotate and you want to put it in the chat, no problem. If you want to get fancy and try to draw it with your pencil, good luck. You can do that too. Health informatics, that's cool. I'm going to delete my, whoops. And then once you're done with your typing, if you go back to the mouse tool, you'll be able to get off of that typing. So if you ever want to click on something again, it's not going to start typing for you. So, okay, chemistry, physical science. I'm going to look in the chat too and see what else you guys have. School nurse, teach intro to health, bioscience. It's great. Okay. Health science theory. Health science theory. That's it. I don't even know what that is, but it sounds fascinating. Veterinary assisting. Okay. I'll look over here. Med and vet sciences. This is great. AP biology, health professions, therapies, chemistry. Pathophys. Okay. Nice. Okay. So we've got a really wide range of teachers in here. That's fantastic. The next slide. So let me just go over here. Whoops. Hello. Hold on. I'm going to go back. We're going to clear all drawings. There we go. There. Now, one more slide here. Are you already incorporating any biotech in your courses? Are you doing a lab? Are you talking about CRISPR? Are you talking about maybe how they're developing some of the COVID treatments or vaccines? What kinds of things are you already doing in your classes that is biotech or biotech adjacent, let's say? And again, if you're better off putting it in the chat, you can do it there, or you can do it on you can annotate on this slide if you want. Okay, so some of you are talking about CRISPR, you're doing ELISA transformation. Nice. Is anyone doing like gel electrophoresis or that kind of thing? I'm just curious to get an idea here. Oh, talking about careers. Yeah, that's great. I'm gonna go over that too. PCR, awesome, awesome. Okay. Okay. So I'm going to, all right, so someone's got a lot there. Biofuels, gel electro, P-glow, DNA extraction. That's great. Okay, so I'm going to clear this, and feel free to keep adding stuff in the chat if you want. I'm just going to go to the next one. Let me move this out of the way here for a second. So when we're talking about biotech, I'm going to do a quick intro on, kind of what it is and what it encompasses, first of all. But these are some of the career pathways or different areas that biotech specialties are found in, right? So when you're talking about jobs with your students, or when you're talking about different parts of jobs, these are some of the things that might come up. So we're talking about drug discovery, drug research, bioinformatics is a huge one that we're always constantly needing more people for. Diagnostics, of course, with COVID this year, we've seen vaccines and treatments and virus research, sequencing, ELISAs. Now everyone knows what PCR and antigen detection, they may not know the word ELISA, but they know kind of the idea behind it. Cancer diagnosis, you might have heard of personalized medicine, right? So these are all the kinds of science, it's sort of the future of where our medical science is going, is this intersection between technology and life science, right? And so biotech is a way for you to kind of bridge that gap with your students. These are a couple of quotes. The one on the far right is one from a student that we actually have in our, I think in our most recent catalog. If I were 21 years old, I go into biotechnology or genetic engineering, and a couple from Steve Jobs and George Church. So Steve Jobs, I think the biggest innovations of the 21st century will be at the intersection of biology and technology. A new era is beginning. And George Church, who's done great strides in CRISPR and just DNA science in general. The rewards for biotechnology are tremendous to solve disease, eliminate poverty, and age gracefully. It sounds so much cooler than Facebook, right? So we are seeing this whole, whoops, let me get this out. When I'm talking about biotech to people who are not sure what that means, as a teacher, you probably do have a good understanding of it, but a lot of parents and guidance counselors and your district level administrators might not understand what biotech is. I usually just describe it as the science behind all of these other sciences that they're already familiar with. So they're probably familiar with forensics, they've seen CSI or something similar. The science that they're doing in the lab, that's all biotech. A lot of the research that goes on behind the health science is biotech, and the diagnostics and treatments, all that's all biotech. Aside from health science, we're looking at biotech in alternative energy and also in crop production, right? So genetically modifying crops and animals as well, and getting more sustainable farming practices. And those also tie into health science as well. If we're looking at making the world a healthier place, that affects all of us, right? And it certainly affects your students. So why might you want to incorporate some of these biotech labs or biotech as a concept into your courses? Like I said, this is really a way for you to prepare your students for jobs of the future, right? So they're looking at jobs that are kind of the cutting edge. CRISPR, for example, I'm sure you've probably heard of. We actually have a webinar tomorrow, and if it's free, you're welcome to attend it if you want to learn more. But that's really cutting edge science, and your students can do that cutting edge science in their classroom. You also can get them involved in project-based learning. So if they're super interested in COVID or HIV, or if they're interested in CRISPR, this gives them a way to kind of go through and look at the molecular biology of that topic, as well as go all the way through diagnoses and treatments as well, okay? Biotech gives students that are interested in health science but don't necessarily want to do the, they don't like all the blood and gut stuff, right? They may not like the medical part of that, but they like the science part. Biotech gives those students an avenue to still get apply their interest in a meaningful way. So you can also really talk about different global and local issues that your students might care about. There might be something in particular. Someone in their school might have been diagnosed with a rare disease, for example. You could have an ag focus if you wanted to, and talk about things in that realm. But this allows you to really tailor what it is you're talking about in your classroom. We have a way, we have programs all across the country that bring in internships into their fourth year of, into their senior year, where they're doing internships for research, right? And so that enables them to do not only the health science rotations, but also research rotations in research labs, okay? Or in different commercial labs as well. And it really gives students a leg up when they're going into college. If they're planning on going into college and they want to work in undergraduate research, or they want to get into med school, this introduction to biotech in high school really gives them an advantage when they are applying to those positions. Okay, so real quickly, I just wanted to show you kind of the leading science and technical jobs. This is the most recent data that we have, but medical technicians and medical scientists are some of the biggest growing sectors in this job market, and it's expected to grow much faster than other careers as well, okay? There is a whole list of, if one of y'all, Yolanda or Taylor, if y'all can put that in the chat, I pulled out 6 of 45 different ones. There's a whole list of careers at this website called biotechcareers.org. And it's really nice because it's organized by what's the minimum level of education that you need. Some of them are high school level, some of them are assistant or associate degrees, some of them you need PhDs for, right? So they're all different levels, and they can go and look a little bit closer at each of those jobs. So it's a good resource for you as a teacher. It's a good resource for your students as well. Okay, so I'm going to stop there and let Nick talk to you more about how he's incorporated biotech into his courses, and then we'll turn it over to Sherry after that. So let me stop my share here. Okay, all right.
Now I'm going to share mine. Get all these tabs out of the way so I can get it. All right. So Lee, thank you for all that introduction. You really made my job here a little easier. I can just piggyback off of some of the stuff you said. Like she said, my name is Nicholas Hanley. I'm a classroom teacher. I've been teaching for 18 years now. My undergrad is in biology and chemistry, but I worked as an EMT through college. So there's always been a medical interest there. And it's kind of what I've used to kind of guide my teaching through the past decade and a half. The last 10 years I have been teaching in a program. We bring 5 high schools together. Students come to us for the project Lead the Way Biomedical Science, as well as some other courses. So I'm Project Lead the Way certified to teach the biomed courses. And the big thing that biotechnology means to be, it's kind of, I have to compete for students with so many other programs. And our selling point is that we're introducing students to the other side of the medical and health fields. Like everybody always wants, every year, 60 students, 10 of them want to be neonatal nurses, 15 want to be neurosurgeons or whatever. They don't think about this side of the health field, and it's growing at a more rapid rate than those other ones. So thank you all for putting this on and giving us the opportunity to talk about these things. So I'm going to explain a couple of the activities I do. Now, I'm lucky enough to where with the project lead the way training, they kind of incorporated some of these things into my classroom already, and I'm able to just kind of use them. But I will also share how I've started sharing these with other teachers in my building, and how we're introducing some of the biotechnology stuff into AP biology, into our health science programs, and various things like that to get them going as well. And then we'll look at how HOSA played into this. So the first big major thing I do in my medical interventions course is we do an Elisa Lab. And so there's a meningitis outbreak on a fictitious campus, and they have to figure out who all is positive for the condition and who patient zero was. So we talk qualitative and quantitative, so they get that background for it. So they're going to learn about the immune system and how it works and how we can use that to diagnose patients and do all the things. But they also get the lab skills behind it. So they're gonna learn how to perform and analyze that ELISA test. They're gonna work with micropipetters, and they're gonna talk about aseptic technique and how we use that, quality control while we do things in triplicate. So a lot of these things, this is the first time the students, like, yeah, they had biology class, yeah, they've had these other classes, but they've never used this. And with ELISA, with everything going on nowadays, we can tie it very easily to common things they've all experienced an ELISA test at this point when they've gotten COVID testing or other viruses. Um, and using our immune system is just a big thing for all the possibilities there that we can do that, like why it reacts the way it does. So um, the big tie in there for real world application of this technology, and students get a feel for what's going on with it. Sorry, my phone in my room is ringing right now, so I'll ignore it. Um, the Let me make sure I'm getting everything here. The real world stuff is really where we want to tie in. Like I said, I have to compete with students with other programs, and when they see us bringing out the fancy equipment that they haven't seen in any of the classroom, that's kind of a positive. So when we have students coming to visit, we normally have some of this stuff sat out so they can see and they start asking questions about it. So that's ELISA is one of the ways we do it. And then PCR and gel electrophoresis is another big draw for us. Testing your own genes, being able to look at and take a sample from yourself, test it, and see what genotype you are. Like it's like the DNA testing they send off to find their genealogy and all that stuff. They just love that part of it. So we do a PTC tasting lab where they collect their own cheek cells and they isolate the DNA and all that, and just going through those steps and then running a PCR. And when you first start out, and I teach sophomores and juniors, some of them don't even know what PCR stands for. By the end of it, they can tell me how it works and they can draw the process and they can do all that stuff. So learning and being able to demonstrate those three main steps in PCR and how you isolate DNA, how does it work on electrophoresis? We put it in this thing and we get these fancy bands out of it, but what actually happens to make that go? So to kind of distinguish what we're doing here from our health science courses, we're doing a lot of the why, the background, the science, which good theme title for this presentation. So we're learning that background stuff. So again, with PCR and gel electrophoresis, we're talking micropipetting again, DNA extraction, loading and staining gels. I even let my students make their own gel. Like they realize it's not like Jello you make at home. So letting them experience that part of it and see it and understanding these concepts. Now, I've taught biology and even AP biology, and a lot of the stuff in there, I can lecture about these things. I can show them pictures, I can show them videos, and they'll understand the material, but they don't own the material. If I give them this lab and they go through and they actually do it, then that's what we're looking at. I've had students from past years come up to me. Like I said, we've been running our program for 10 years. So we have students that are now in medical school and they're going and reaching those things in pharmacy school or graduated pharmacy school. And one of the things that they come back to us and say is, they felt prepared for college. They went into labs, they knew what the equipment was. Everybody else is kind of like looking around, like, what do we do? They're over there like already analyzing data. So they understand the stuff, and giving them that experience is one of the beneficial things. And like I said, a major draw to this. Let's see. Um, I could go on for 20 different other things, transformation, and everything else that we do. You know, making bacteria glow in the dark. That's the kids just love that part of it. But getting to see those things and experience that is what our kids want to see. And like I said, they all start off as neurosurgeons, and by the end, they realize that there's other things out there. There's, you know, bioengineering. There's all this stuff here where they don't have to work with patients. They can work with other things. So lots of good stuff there. So from our student perspective, our population, at least in my district, we're trying to reach out and find those underrepresented populations in the medical field and everything. And maybe students that have never really thought about a career in the medical field because all they thought was, I can only be a doctor or a nurse. Well, there's other things there. So we're working out, but this content, it's relevant to any demographic. It doesn't have to be, you know, African American, white. It's not about that. Make sure I get all my notes here. So our population varies year by year. So we're trying to reach out to those non-traditional students. The impact on students from here, from a college perspective, again, we're learning college level skills now. We're not waiting. They're doing gel electrophoresis. They're doing stuff in high school that I didn't do till I was in my master's program in college. So as technology gets better, I know we keep doing that, but they're still experiencing those things and getting to do that. Some things we have an advisory board with some of our local universities on it, and some of the comments we've gotten from those members is that they've been impressed with our students' lab skills. They've hired our students as lab assistants because they could trust them to do what they're doing because they have this background. Our students are just confident. They've come back and they've told us, well, you know, college wasn't as bad as I thought it was going to be because I knew how to do the stuff. I understood what they were asking. Career-wise, we've set up a lot of externships and internships through this. And again, because they know they can depend on our students, they're giving them better opportunities. Maybe they're getting to go a little further in their internship, in their externship, because they're asking the right questions. They're talking about the right things. And then credentialing wise, with our program, we come out with the base certification. But the big thing I want to talk about is this HOSA connection. I've been working with HOSA for 10 years now. One of the things, the health professions event is kind of where I've been focused at the state level. The biomedical laboratory science event has changed a lot over the last 10 years. And the way I'm seeing it change is more towards this biotech stuff. So there's a day in the not too distant future where I see, instead of the skills being what they are currently, like naming lab equipment, I see them running a gel and analyzing a gel. I see them doing that type of stuff. So there's connections there with some other things. Again, yeah, I'll come to that. It's more on the teacher slide next. Sorry, I'm getting ahead of myself. And then from a teacher perspective, student engagement is key. If you give me 30 students, if you give me a way to get them engaged, I can teach them a lot better than if we're just hoping they become engaged. And again, playing with that fancy lab equipment, just seeing that stuff, letting them, you know, they put their phones down because they want to know what this machine over here is and what it does. So their engagement improves, which improves everything in the class, and they start asking those deeper thinking questions, and that helps me as the teacher. Training wise for this stuff, Project Lead the Way did a good job, but there's also the when you get a kit, the introduction material and stuff that comes with it is wonderful. There's webinars, there's training resources. I've never felt unprepared to do a lab. I know some of my HOSA people might be a little hesitant to do a heavier lab-based thing because they're not coming from the science background like I am. But I promise you, you'll have time to look through it and you'll be ready to go when it's there. But there's the training out there that's available to you if you need it in lots of places. Collaboration wise, I've collaborated with my AP biology teachers here. A lot of the stuff that they teach, they may not have the lab kits in their curriculum to do it, but it ties together. So we'll kind of work on like a joint thing where my students teach them about this part, and then they teach my students about something else. Health sciences, same thing. And this ties into HOSA. My center has its own HOSA chapter compared to our high school here. So where there's actually two HOSA chapters based at this building. I don't have a lot of training in like the traditional health science stuff. And some of my health science people don't have the science background that I do. So what we do is we kind of trade off people. Like if they have students interested in a BioLab science event, I have days where they come to me and we work together on that. And then there are other things where, you know, I send my students to them. So just having that relationship where you feel comfortable doing that leads to maybe more collaboration in activities and stuff. So, and then like I said, there's lots with HOSA we can do. I've listed a couple of different events. Biomedical science is the big one. It kind of, you know, is kind of named for it. It used to be called biotechnology. So it's there, but there's a medical innovations event now where the kids develop their own innovation to a problem. Clinical specialty is for those techniques that aren't tested on anything else. So if the kids want to show how to do PCR, they could do that through the clinical specialty area. So pharmacy science, biomedical debate, forensic science. What I've been seeing is that even the topics being discussed in some of the like prepared speaking events are starting to have a biotechnology twist to them. So being able to involve this or show them how to do this wonderful thing. Community involvement. Our advisory board has been huge for us. We try to get people in various fields, not just hospitals, but like we have a company, Nephron Pharmaceuticals, around here that has been good to us, that we're able to partner with, and they give us information and feedback. And they've hired some of our students to work over the summer and things like that because of the connections. We've also used some of these people as mentors for HOSA events. They've helped us, you know, go through, and yeah, I think I have a pretty good background in some of this stuff, but they do it every day. And if they want to come help, I'll sit down and learn from them too. So any additional information I can get from them is always good for me. But as the medical field is growing and technology is becoming so important, any way we can connect our students to that, and even I almost feel like they're connecting me to it because they're driving me to find this stuff out. I've never been a teacher that has to know all the answers. Like if they have questions, I want them to ask it and we'll find the answers together. And even that endears them more to the program, to everything. And like in my classroom right now, it's the 60 sophomores I have. I want them to be smarter than me. I want them to go on and be the ones that fix the stuff. So if they have an interest in this, anything I can do to kind of spark that and fan the flames and do that's my goal for what I'm doing. So biotechnology is wonderful, and the more we can get involved, and like I said, even if you don't feel comfortable with the background, talk to that AP biology teacher, talk to the health science teacher, or your project lead the way teachers work together. It can only be better for the students in the end. So Lee, I think that's all I got for y'all. So I'm going to stop.
Awesome.
there.
Thank you so much. That was great. I loved hearing about how you've 60 students. That's a lot. Yeah.
3 classes though, so not in the same class.
Yeah, I figured. Okay. No, that's fantastic. Thanks so much for sharing your experiences with that. And we are going to turn it over to Sherry now, and she's going to talk to you guys about a COVID case study that is it's a lab that Biotech has that we've kind of adapted, and Sherry's put, of course, her own little unique spin on it as well. So I'm going to turn it over to her now.
Well, hello everyone and welcome. So I will begin by saying I am not a health science teacher, but I'm a full-time biotechnology teacher. My name's Sherry Ann. I have been teaching for 30 years. And with the most recent 25 at Brebeuf Jesuit in Indianapolis. I'm going to share this document with you in a couple minutes, but I want to point out a few things before we get going on it. Let me see. So I created this biotechnology course in 2003. It's approximately a half of the seniors at our school take it. It's a full year course. It's lab intensive. So I just want to give you some of my context as we move forward. And if at any point you have questions, please don't hesitate to ask. I'm happy to be interrupted. And Lee, if you would watch the chat for questions, that would be great. And then if you would give me a 5-minute warning of when I need to stop, let me know. Thanks. I have 4 sections, which range in size from 19 to 24 students, again, most of whom are seniors. It tracks purposely. So I created this course in 2003 because at the time, so I'm at a private school of 800 kids, 9 through 12, again, in Indianapolis. And what we were finding is that seniors were either taking APs, whatever, or they were in a class together with sophomores taking zoology, which the content was fine. But then you can imagine the merger second semester when you have second semester seniors with sophomores. And so the person teaching that was really having a hard time. So I thought, well, I'm going to create biotech. And so I've been successful in capturing a range. So I've got kids who double up in science for taking AP, biology or what have you. And then also taking biotech because they want to major in science. And then I've got a whole lot of kids who either come into the course thinking, I don't want to major in science. Some change their minds, which is fun, but it's also fine if they don't. I'm not trying to convert. And what I want is I want literate science citizens at the end of the day. And so all of my class is highly lab intensive, and I always try to put a real world spin on it. So BioRad, for example, is an excellent place to get labs because they had an opioid kit, and then they put a COVID spin on that, which is what I'm going to highlight. And so I have many students who, so 99% to 100 of our kids go on to college each year. And the ones that don't, generally it's a gap year. But they will say, you know what, I'm majoring in business at IU, Indiana University. And I'm so glad I did the GMO lab because I understand the science of GMOs, even though I'm interested in the business aspect of it, it really came in useful to understand the science, which, that's again, the goal for me as a science teacher. All right, so that gives you a little bit of context of where I'm coming from. And then I've listed, so I have 60-minute class periods. We meet 5 out of every 8 days, and they're 60-minute classes. And then I listed my major topics there. The context for which what I'm about to talk about, my students have done other things, but the major things, they've run gels, they've learned about DNA sequencing, they've done some labs, they've extracted DNA, they've run PCR, and they've done blast searches in GenBank. Okay, so that's my context. I'm going to share this document with you now, and then I'm going to put it in the chat. Good, I've done the right version. And then I'll talk a little bit more about how I've set this up. All right, where I am missing my, oh, there we go. Okay. I'll wait a minute if you would open it and make sure that you have access. Thank you. Yes, we're good. Okay, so I want you to keep in mind, as much as I would love to teach all of this, this session is about exposing you to this case study. It's going to be fast, and but also the way that I've designed this handout, you should be able to go back step by step and see what I've done, and I'll explain that more in a minute. I do want to start with, because you all are health teachers or health science teachers, BSCS, if you click on this link, there's a middle school version as well. They created, I field tested this a year ago at this time, COVID-19 and health equity. It can be up to like a 5-week unit. It was phenomenal. So you explore the disproportionate impact of COVID-19 on communities of color. They set it up so you're looking at 3 different zip codes in Chicago, and then 3 counties in northern Indiana, which turned out great for my kids since we live in Indiana. And you can see so it's all research-based, and you can see that systemic racism indeed is an issue. And you can see the number of COVID cases within zip codes. You can see the number of deaths, access to hospital, food deserts. You can then go add redlining, etc. So I highly recommend you look at this. All right, so my students last year, when I did the case study I'm about to discuss, we'd field tested this, but it's not mandatory that you do that in advance for their understanding of this case study. And again, that is free. Okay, so I want to go through my document here. The kit for BioRad, if you click on Science of Opioid Dependence, I'll just do that for you. You're going to get the PowerPoint that they've made that takes you through the directions on how to set up this particular lab and then case study. And I've made modifications. Okay, so but there's the original for your use. And then if you scroll down to the second page and you click on biology of SARS-CoV, this is going to take you to HHMI Biointeractive. And these are all free resources for those of you who are unfamiliar. And so clicking on that, their website was down, which was so unusual a little while ago. Okay, so there are 4 parts to this animation. The 4th one was actually just added recently. It's vaccination. I'm going to point out evolution, infection, and detection. And I go in a little bit different order than what they have. I want to point out that they have educator materials, so there's a lot of background information. And then they've got 2 versions of worksheets, student worksheet 1 and student worksheet 2. In the document that I made for you, I copied and pasted the difference between the 2 worksheets, which I'm not going to highlight now, but it's there for your reference if you decide to use this, see which one is better for you. And then in this document, if you scroll down, you're going to see the one that I created. One of the wonderful things HHMI has done recently. Now, they don't have it for all of their resources, but they do for their most popular, or if you ask them to, they do it by recommendation. This resource Google folder that I'm pointing out, these are their documents that are Google Docs, so you can modify them freely at will. And that's what I did. So in my document that I've shared with you, you see the version I created. So I actually took parts from their student worksheet 1, student worksheet 2, merged them, modified them, and then I added a whole another section. My students have done blast searches, and I wanted them to take, and I'll tell you this a little bit later, I wanted them to make a distance tree of results of some of the CoV-2 viruses that we've seen here in the United States. Okay, so that's there for you if you want it. Okay, so now the PowerPoint that I use with my students, the one, again, it's been modified from BioRad. You can see that link, which is what I'm going to go through now. And anything that I'm using within this PowerPoint, I've pulled out on the slide. So if you see something of interest, you can quickly just click on that rather than having to fumble back through the PowerPoint. And I am going to keep it like this. I'm not going to put it in full PowerPoint version presentation mode, just because it will help me go a little bit faster, quite honestly. All right, so this is set up for students to think about tracking the spread of SARS-CoV-2 using reverse transcription, PCR, and gel electrophoresis. This is based on a true scenario that happened in January of 2020. And so an individual ate dinner at a restaurant in Guangzhou, China. Later that day, the person experienced fever and cough and went to the hospital. Suspecting COVID-19, the other customers in the restaurant, including 1 wait staff and 1 cook, were quarantined for 14 days, and then swabs were collected. I show students then a picture, this is from the published paper, of the restaurant, that the area of focus. Okay, so the letters are tables, the numbers are seats, and you can see like the kitchen entrance, you see the waiter and the cook. Okay, so they've got that. The other thing is I taught this in the spring. I haven't yet taught it this year. And this was a hybrid situation. So this lesson was specifically created knowing I would have half the kids in front of me, half at home virtually, and then it wasn't exactly that they'd swap the next day, but we'll just go with that scenario. It's more complicated, but you could do this 100% virtually, where then maybe as a teacher, you're running the gel and showing them. You can do it in hybrid situation, or of course you can do it 100% in person, where everything then I got here is electronic. Okay, so I tell them their task is they're working in the lab. These patient samples have been collected. And again, remember, I'm going fast through this. And they're going to use gel electrophoresis to determine which patients were infected. Now, PCR has already been done to these, so they're not doing the PCR with this particular kit. And then as a class, they're going to pool their data. And so one of the things I like is that not all 32 patients are given to, let's say, one group. We're dividing them among everyone in the class. And depending on your resources, et cetera, maybe you divide 32 over the course of many classes, or, you could figure all that out. So, the question comes up, coronavirus, what's in a name? And so we talk a little bit about that. And this is where I now go off to HHMI, that I mentioned that there are 4 parts to this interactive. I will just quickly, we're not going to go through it. In a perfect world, we'd have more time and we could certainly go through this. I did give you in the document that I shared the time for each of these. And so students, and I will say that because I had half the kids in front of me and half at home, I did all this lockstep with them. I would pause and then I shared you the document I made for them for this. They would then answer and we'd go over questions. But to save time, you could certainly assign it for homework, etc. So this is about 2 minutes and 43 seconds. I'm just gonna show you, like, this is what it looks like. Okay, so this is the style. All right, so they watch that either again by themselves or you do that as a class, and they answer some questions. So now they've got some background on the infection, and then in another 2.5 minute animation, we move on to detection. So this is where if you do ELISA, you can bring in ELISA because there's antigen detection, the gold standard, of course, PCR, and then antibody. And in the handout, they learn the pros and cons, if you will, of each, or what information it tells you. So I know a person has an active infection, PCR would tell me that. Do I have antibodies? Okay, et cetera. So they learn the differences among the tests. And then we review PCR. Remember, my students have already done this. This particular animation is on the BioRad website, and I believe was part of their original presentation. So we review that. And then I found, which I think is a really awesome animation about reverse transcription PCR. I stop it at 4 minutes and 15 seconds because I've already done, in this case, BioRad's barcoding lab. If you're not familiar, you take samples, you extract DNA from different fish samples. We use sushi, which is commonly what people do who use this kit. Go to different sushi restaurants, and we extract the DNA and then amplify a certain section, run a gel to see if we're successful with that, and then that gets sequenced, and then we run a blast to see if the fish has been mislabeled. And every year I've eaten mislabeled fish. But anyway, so they use a spin column in that. And so this animation shows using a spin column. Of course, you're trying to purify RNA instead of DNA, but I, go through it. It's just a lovely connection with that previous BioRad lab. And if they've not done that, they can see what a spin column is, et cetera. And then putting it in the thermal cycler. All right, so we do that. And then, and again, all these links have been pulled out on that document I shared with you. We talk a little bit about, all right, what is it that we're doing in terms of amplifying? Well, we're amplifying 2 regions. One is the SARS-CoV-2, which is a band size of 530. Again, my kids have run gels, so they can ideally predict where bands are gonna migrate relative to one another. And then built-in control for JPDH, which every person will have this. We have to have this, right, in order to be functioning. So every person is going to be positive for this. What's going to set people apart is whether or not they have a band for the SARS. So then what I do is and this document, I have them, if you go to the document I gave you, this is student document to predict gel results. If you open that, that's an electronic document where I want them to predict before we run the gels. So in lane 1, we've got the molecular weight ruler, and 2, we've got the GAPDH positive control. And by the way, at the bottom of the document I gave you, I list some differences of what I did versus what BioRad, how how they label some things they suggest versus what I did. So any changes I made, I've listed at the bottom of the document. That
Hey,
I gave.
Sherry, about 5 more minutes.
Okay, thank you. So then they predict, okay, what these bands would look like, and they can do that electronically using CAMI, or you could have them, do paper copy, what have you. But again, I want to make sure they're understanding what they ideally will be seeing in various scenarios. Okay, all right, we'll go back to this. All right, and then I remind them of their tasks, and then I tell them we're going to collect data. So we run the gels, and then they write their results, who's positive. You've got 32 people who were in the restaurant, and A1, C2, etc. So they write their results on the board, and we collect that. And then I tell them, all right, we've got some more information. I tell them a little bit about the family who traveled from Wuhan, that the index patient was a person A1, exposure of other families in the restaurant. I also tell them tables are approximately 1 meter apart. And so they know how far Wuhan is from Guangzhou. I tell them it's 520 miles because, maybe it's a 5-day trip. And so that gives them some ideas of thinking. And then I have them do small group data analysis. And I've given you a copy of this. I won't pull it up, but I have a student handout of this. And they then can color in all the positive patients. And so they do that, and then they get a sense of who's sitting where and who's positive. And then I ask them in this handout, which is listed here, but it's in a handout form, to propose a possible explanation for how the virus spread. Then give a second one. Let's not just settle on the first thing that comes to mind. Let's think of the second one, and then any other additional data they might want to know to help them determine which proposal is more likely. So then we compare where people were sitting. And then I tell them a little bit more information. This all comes out of the published paper, that the only known source of exposure, and by the way, they all share out their ideas, so it's fun to hear. And they tell them, okay, the only source of exposure for the affected persons and families B and C was patient A1, because they thought, well, maybe someone came in at one of the other tables and it's coincidental that they were exposed. And again, I've told them not only the distance between the table, which I've already mentioned, but how long in terms of time was the overlap. These families are sitting there. Here's now the paper. There's actually a second one. So this is the one in July. And I tell them that, okay, because they ask that some kids come up with the air conditioner, because that's in that original form. And I tell them, oh, okay, they tested it 3 times, the outlet and the inlet, and those are negative. So COVID wasn't being blown into the restaurant. And so what they can see, though, the air was moving over C, A, and B tables. And then that's the actual other part of the restaurant. And then what's interesting is in November, there was a follow-up paper because there was a letter to the editor saying, you didn't point out these things and those things. And for example, students want to know, well, maybe how many times was there videotape of people going to the bathroom? Did they touch the handle, et cetera? And so they said, yes, we've got videotape. And so a lot of those things are addressed, and it also shows how scientists are keeping each other accountable, et cetera. All right, so, and I love the use of the actual published results. Now, this was something I found that's, I think, pretty fun. This is on your document. Oh shoot, I don't know how fast I can get this. Kind of clunky, sorry. Which I will open. I am almost done. So this is 3 different scenarios of outbreaks. And when I scroll through, you'll notice I'm going fast here, but you can see, for example, this is in like a boardroom. I'm sorry, in a cafeteria. And you can see the floor plan, where they are, etc. And then our restaurant is right here. So you can see as I'm scrolling what's happening. And then they end up with on a bus. There's one with a bus as well. So that was a fun follow-up. And then ultimately, I end this with the HHMI, the third part I mentioned, evolution, because now, we imagine this started with someone in Wuhan going to Guangzhou, and then the United States, the first detection we had was in Washington State. So I give them the sequence. Well, they actually go in to GenBank to get the sequence for Washington State, Colorado, California, Idaho, and I'm missing one more. And then they can build a, right there in GenBank, they can build a tree to see how closely related they are. After being given a few sequences, they're given like a small section of each sequence, and they see the number of differences, and they first predict which one they think is most closely related to Washington, so how the evolution occurred, and then they actually go into GenBank to build that tree to see if that supports the prediction. So that is it, except one last thing on the document I gave you. I do give you one more additional resource, which I did not use, but I want to point out. If you're familiar with Virus Explorer and HHMI, they have added coronavirus to that. Okay, that's it for me. I'm happy to take questions.
Thank you, Sherry. That was a breakneck presentation with jam-packed with stuff. But I just saw Sherry just presented this to us, to BioRad people and some other teachers yesterday. And I was like, this is such a cool use of the kit. She took a BioRad kit that we had already adapted to teach COVID with, and just kind of added all that other stuff to it and made it that much more rich. So thank you for presenting that. And I mentioned in the chat, we'd like to have Sherry do a more full presentation of that, where it's not as rushed because I won't be blabbing. So we're hoping to get that lined up in early 2022. So stay tuned for that as well. We'll be sure to put it on our website, and I'm sure hopefully announce it through HOSA too. So let me just go back to where I am, if I can. Oh my goodness, hold on. I've got to find where's the rest of my windows here? Here we go. Okay. Share. Okay, so I wanted to just real quickly talk a little bit about BioRad as a company. I don't know how many of you are familiar with us. I know some of you, I'm sure, have used our products before, but in case you haven't, I just want to go over that real quick. Whoops, here we go. So our company was started by husband and wife, Dave and Alice Schwartz, back in the 50s. They started growing tobacco mosaic virus. They were both they both graduated from University of California at Berkeley. And this is like how they started. So this is how the company started. You can see that our logo was not named because we are radical, but because of radiation. We no longer do that, thank goodness. So we sell products to research labs and clinical diagnostics, hospitals, all that across the world. So they're based in the Bay Area. Hercules is just northeast of San Francisco, which is right here. That's what the campus looks like. And we have two different realms that we work in. So we do a lot with life science. Those are the researchers in academia, at the CDC, all that. And at different companies too, Genentech and those kinds of companies. And then we have a diagnostics group that supplies different equipment and consumables for health science. So I'm not going to spend a lot of time on this, but this is, kind of our life science, all of our equipment that we do. We do a lot of food science testing, food testing as well, water testing. We're doing a lot of wastewater testing right now with COVID. And then for clinical diagnostics, we have a lot of blood banking, blood typing, all kinds of infectious disease, ELISAs and things like that too, and QA. Okay, so that's BioRad as a company. Our group, our education group, is just a real tiny part of that. So BioRad has probably around 8,000 employees, and there's about 15 of us in education, okay? But we use all the same tools and equipment that the researchers use. So we try really hard to make it as authentic as possible. I think Nick and Sherry can both attest to the fact that having students use the real tools that they would see in a job or see in industry is really useful for them. So we try to make it as that transition as seamless as possible. Okay, so let's just more about clinical diagnostics. Now, I want to talk about how we can help support you in your classroom if you're doing this. So obviously we have someone like Sherry who's been through, Biotech for over a decade now and doing all this with our students and really, really advanced. She does not require any handholding from us, but we have all been in a situation where we didn't know how to pick up pipettes, right? So we are, our goal is to train everyone from any entry point, right? And Nick's been teaching this for a while too, so he's really advanced in these techniques too. But we try to make it easy for you. There's 3 people who do what I do across the country. We are going there in person. We do Zoom. Sorry, my dog's barking in the background. We've been doing a bunch of Zooms the past 2 years, and we're happy to help show you guys how you can not only bring the science into your classroom, you know, just talking about how this might fit into a lab, but we can also sit there and hold up pipettes and, you know, demonstrate how to use them. I have the whole lab stuff sitting in my dining room right now. So I do spend a lot of my time going and actually showing people how to do them. We also do webinars. Like I said, I have a CRISPR webinar tomorrow that's hands-on. I sent materials out to people. People can also attend that and without doing the hands-on part and just listen and watch. So we try to make that as easy as possible. We know we have teachers at all different skill levels. My background before working for BioRad is I was doing coronavirus research way before coronaviruses were cool. So I do have a background in molecular biology, virology research. When I was doing that, no one knew what coronaviruses were. It was a different world. And then I was also teaching AP and honors biology. So all of us have some experience in the classroom and doing research as well. So we kind of try to tie that together. Just real quickly before we end, I wanted to go over, what time is it real quick? Okay, I'm going to spend a couple of minutes here. I wanted to go over some of our kits. Some of them Nick and Sherry talked about, but ones that might fit into your course. So we have Genes in a Bottle, which is a kit where they're just collecting DNA from their cheek cells. Okay, and putting in this cool little DNA helix necklace. That's one that's really easy. We have all the way down to elementary kids doing this, all the way up through grad students, and they all get a kick out of it because it's their own DNA. Probably our core kit, our most famous kit is P-Glow, where you're taking a gene from a jellyfish and putting it into bacteria to make them glow. That's the one that Nick mentioned that his students really enjoyed. This one I like to teach about insulin. So this is how we make insulin as well. We're not taking a glowing gene from jellyfish, but we're taking a human insulin gene and putting it into bacteria. So that's how Genentech got its start. So this is kind of nice for them to understand the science behind what goes into a lot of our drug development, right? This lab takes that to the next level and talks about how you purify drugs, right? So in this case, we're purifying that green fluorescent protein. We have ELISA labs. These use real antibodies and antigens. You can teach whatever you want with these that, you know, would be dependent on either antibody or antigen detection. So we've done COVID, HIV, H1N1. We have even done, just for fun, like a prion that is being transmitted in the zombie apocalypse, right? So just, you know, it can be whatever scenario you want. They have it where they can actually pass samples around the classroom. These are not bodily fluids, obviously. They're samples with a little bit of antigen in it, and they trade samples. And so you can just infect 1 or 2 students and they see how far it travels around the classroom. And like I said, it's a real antigen antibody interaction there. We have different Bradford assays. So this is looking at how much protein is in different various foods. So looking at the global problem of, food shortage and malnutrition. Our opioid kit is the one that Sherry used, and an adaptation of that. The actual kit was designed to look at the science of opioid addiction and how there's a genetic predisposition for some people to become more opioid dependent. That kit is just a gel electrophoresis kit. So Sherry had all that wonderful extra stuff that she tied in, but the kit for the opioid one or for the COVID restaurant scenario, the lab experience is them just running a gel. They don't need to do PCR. They don't need to do a gel restriction digest. It's literally just taking the DNA samples, adding their dye, and running them on a gel and analyzing it. So just looking to see if you get 1 bands or 2. Okay, so it's an introductory lab that you can make as sophisticated or as simple as you want to. We have CRISPR, and again, the tie-ins for this are just, the gene therapy and the personalized medicine tie-ins are huge. We just had huge advances with sickle cell anemia as well, using CRISPR to basically cure someone of that. So again, that webinar is tomorrow. I'll put the link up for that if you're interested in that. And Nick had mentioned PV92. This is a PCR lab where they're actually looking at their own DNA and amplifying a region in there doesn't code for anything, so it's safe to look at, to kind of see the differences, genetic differences between them and students all across the world, actually. So that is our kind of our kits that tie into health science. We're always looking for new ways to adapt kits we have. If you have ideas or questions, please don't hesitate to contact us. We would love to help you kind of think about how we can turn some of these kits into something that might teach something that you're interested in, or that's more relevant to your class. We have this link. If one of the BioRad people can put this in the chat, this is a link to all of our classroom resources. We have models, all kinds of things like that. We have YouTube videos of, a lot of them are just biotechnology techniques. If you want to know how to use a micropipette, there's a like 2-minute video on there, how to pour a gel, all that is online. Okay. And, oh, and I think Taylor's also putting in a survey link too. We would love to get your feedback on that. So please look for that. We have events coming up as well. So our CRISPR seminar tomorrow, and then one next week. We'll also do another one in January. I know this is hard to look at. I'll send this PowerPoint out to you guys. So, and finally, we have partners that we work with as well. So Biotility does the case certification that Nick mentioned earlier. This is a biotechnician assistant credentialing exam, and it serves as a credentialing exam for your CTE course if it's approved in your state. We're working on getting that approved all over. I think it's approved in about 8 to 10 states right now. Innovate Bio is a good resource if you're looking to do biotech in your class at any level, high school, college, whatever. So that is it. And I know we're short on time. I'm going to be here a little bit longer. If you want to ask questions, I'm happy to answer. I do want to be respectful of your time though. If you don't mind, there is a survey in the chat. It's that Survey Monkey one. If y'all can, it's not clickable for some reason. Let's see.
We've had this issue with Zoom.
I think it has to have the HTTP. Let's try this and see if it works. There we go.
Just did it. Taylor just, yeah.
Oh, got it. Okay, thank you.
Sorry about that.
So if y'all wouldn't mind taking that, that would be great. We'd love to hear your feedback and know how else we can help. And I'm going to stick around for another 10 minutes or so, if that's okay. Is that okay? Hopefully. And then y'all are welcome to ask questions. So thank you so much, though. We appreciate you coming and hope to see you again soon. And if you have any questions, I'm going to stop sharing. If you have any questions, feel free to unmute yourself and just ask away.
Leah, can you hear me okay?
I can, I do.
Okay, so I teach at a rural community in Nebraska. 5 high schools kind of pulled resources together to create a CTE school. So twice a day we get kids in, juniors in the morning, or I'm sorry, seniors in the morning, juniors in the afternoon. One of my classes that I was looking at trying to add this is just what we call an Intro to Health Careers class. Mm-hmm. We're very fortunate here. We have a community of 6,000 in people, but within that we have 2 hospitals that were within half hour of each other. That our kids are in job shadows nonstop. So my kids have been in surgeries, been in lab, been in whatever areas in the hospital that we can get into. So where I'm going with this is the one thing that I don't have in my area is a lot of, well, at least I have not identified biotechnology. Let's say like research. I know we have some research being done on cattle, probably about 5 miles from here. I'm just starting to look into what opportunities can they provide for our students. Again, this class is just an introductory class to show them all kinds of things that are so cool in the health field.
Yep.
So if that's what I'm looking at, and I want to add one thing from what I heard everything today, give me one suggestion. I mean, all those things were fantastic. My biggest problem is I don't know what biology background my kids have when they come to me, because they're coming from 5 different high schools.
Yep.
Obviously I can do some quizzing of the teachers and those sort of things to get some ideas, but I guess what I was just saying is something that's basic but yet challenging or interesting to the students? If just one thing that I heard today, what would you suggest?
But as far as a lab goes, or just a topic in general, what do you think?
Yeah, I'm thinking I like to do, obviously, like all teachers, lots of hands-on stuff. So my kids are, we're injecting, we've got the arms, we do that. I'm just teaching kids, I guess not teaching them how to do it, giving them experiences. So I want to give them an experience in biotechnology. I know it's not, there's so many areas I know, and I don't have time to go through all of them, but just an experience. What would you suggest?
So I would say that PGLO is by far our most popular lab with teachers and with students, just because it gives students, it only takes a day. It doesn't require any equipment. They look at their results the next day. Well, really 2 days later if you don't have an incubator, so 2 days. And it allows you to talk about how we make so many of our different drugs. That's one that I would put high on the list, just because as long as they've had 9th grade biology, it's one that they really need to understand that DNA is transcribed into RNA, which is translated into proteins. That's kind of the core science bit there. There's another little piece there that allows you to turn on and off genes. I can tell you how you can sort of skip over that information or include it. It's really important for the students that are taking like AP to understand. It's also important. It's good information for health science students as well, for sure. So that's one that I would really consider. The easiest lab that we have is the genes in the bottle lab, which is just taking the DNA from their cheek cells. And that's another really fun one. They really like doing stuff with their own cells. Like the PV92 lab is always really interesting. That's a PCR lab, more advanced, but they really like it because they're looking at their own DNA, right? That's one of the key things, I think. I don't know. I'll let Nick and Sherry chime in though. What do you guys think? Sorry to put you on the spot.
I think you could do a lot of things. I also have students coming to me from 5 high schools, so I can kind of relate on that aspect. What we tend to do is, like, regardless of the lab, we kind of use the students. Like, you have your more advanced students kind of can guide the other ones through it. You even have like where the transformation lab, just reviewing that trinity of biology, the transformation, transcription, all that stuff. You can tie the lab in to the needs of your students based off of what they have there. So really any lab you can tailor to it. It's just how much some of the labs might require you to do a little more tailoring than others to meet all those needs. But the transformation, like she said, covers those 3 basic things that you talk about in all biology classes. ELISA is something you can tie into everything that's going on right now. So it's just, you want to meet a current topic and then get them to that point, or do you want to talk about something a little broader like the medicine? So I don't think you can go wrong. It's just, where do you want to go with it?
Yep.
So ELISA or PGLO, if you don't have access to any gel electrophoresis equipment,
I'll interrupt you there. I have all the equipment. I'm a biology teacher. Our project Lead the Way. So I have like tons.
You have thermal cycler.
Yep. Got it all. So I guess my question is, kid without knowing the background, and some of my kids will take Project Lead the Way, some won't. And so I don't want to, so I'm kind of trying to stay away from some Project Lead the Way stuff but yet maybe something that's similar to it.
Do you have, you mentioned, I think you said you're in a rural area. So is agriculture big? So then GM Foods might be a really nice tie-in for your kids.
That GMO lab that we have is probably one of my favorite labs to train teachers on. It has really good controls. It helps them really understand the importance of positive and negative controls. And again, they're bringing in their own food. And so they can bring in produce or chips or whatever they want and test to see if it's genetically modified or not. So that's a really engaging. Any lab where they're bringing in their own stuff is really fun.
And that utilizes PCR as well as gel electrophoresis. So you'd be getting 2 nice techniques in there.
Thank you guys for your suggestions.
Absolutely. I'm going to put the link to the survey. Oops, hold on. Let me try that again. One more time, if y'all don't mind hitting that up if you haven't already. I'm also going to, if anyone's interested in the CRISPR webinar, you're welcome to just shoot me an email and I will be happy to add you to that. I don't have any more kits to send out for tomorrow, but we will have one in January and I could send you the sign up for that as well, that I'll send you a student workstation for it. Any other questions or comments or? Well, okay. Thanks so much, everyone. I appreciate your time and I hope that was helpful. I enjoyed hearing what I always enjoy hearing what our teachers are doing. So that's great. Thank you so much again, Sherry and Nick. I appreciate your time as well. And hopefully we'll do it again soon. Bye, y'all.
Hi, Leah. I'm sorry to join so late. I was teaching into 150. Hi. I am going to meet, I think I'm going to be meeting with Bobby Crandall or on Thursday tomorrow anyway, or Thursday. But he had said that this was also going to be recorded. Is there a way to find that recording?
I imagine, is Bobby still here? We will get it out to you somehow. So I know it was definitely recorded. And so we'll make sure that we upload the link or email that to you and I'll send the presentations as well.
Great. Thank you so much. I appreciate it.
Thank you.
Sorry about that.
No problem. All right. Bye, guys.
Thank you, Lee, Nick, and Sherry. Thank you.